So feel free to follow along. You can use this to check your work, or if you're confused about a problem, this is a good video that should help you understand a problem. So we're just going to start from the beginning. One thing before I start, you'll notice that the numbering might be a little different than what you see on your packet. The problems are all the same, but the numbers in front might be a little different, so please don't be confused. So I'm just going to start from the top with Skill 4A. It says circle the hypothesis and label it P, box the conclusion and label it Q. So the hypothesis is the part that comes between the words if and then. So I'm going to start after the word if, and I'm going to go all the way until the word then, and I'm going to circle it, and I'm going to label it P. So that's my hypothesis. We might ask you to write it out. So if we said, what is the hypothesis, you would write out 2 lines intersect to form a right angle. The conclusion is what comes after the word then, so I'm going to box my conclusion. In this case, it is they are perpendicular. So if we asked you to write out the conclusion, you would just write they are perpendicular. So Skill 4B says draw a Venn diagram for the conditional statement in number 1, or it might just say for the conditional statement above. So we're going to do that. Whenever we have a Venn diagram for a conditional statement, it's going to be one circle or one box inside of another circle or box. So here's my Venn diagram. I'll make sure I can fit everything in. The stuff after the if goes on the inside, and the stuff after the then goes on the outside. So the hypothesis goes here, the conclusion goes here. So we're going to put here 2 lines intersect. 2 lines intersect to form a right angle. On the outside, we put the conclusion, which is they are perpendicular. Okay. So what would have been better would have been just to write lines that intersect to form a right angle, and outside we could have just put the perpendicular. Okay, so let's move on. Skill 4C, 4D. Write the different forms of the following conditional statement in symbols and words. Well, let's do a quick review on the side really fast. We know that the conditional, our original statement is P to Q. We know that the converse is when we switch the order, so Q to P. The inverse is the negation of P to the negation of Q. Remember, this arrow means if then. So really, if the negation of P, then the negation of Q. And the contrapositive is when we switch the order and we negate both statements. So now that we have our little cheat sheet, the rest should be pretty easy. So let's fill in. The converse is Q goes to P. The inverse is the negation of P to the negation of Q. And the contrapositive is the negation of Q to the negation of P. Now, it would be helpful for us to look at this and label our picture. So remember, the P, the hypothesis comes after the word if up to the word then, and then our conclusion comes after the word then. So now let's fill in what we know. This is going to be if Q then P, so I'm going to start with the word if, and now everything that goes with Q. So if I am not afraid of heights, then P. So then I ride on the Ferris wheel. Fantastic. Okay, let's keep going. Inverse. Negation of P to negation of Q. So we're going to start with if. I want the negation of P. Well, since P is I ride on the Ferris wheel, the negation of P was I do not ride on the Ferris wheel. So if I do not ride on the Ferris wheel, then we need to negate this now. It says I am not afraid of heights, so the negation would become I am afraid of heights. So then I am afraid of heights. Okay, lastly we have our contrapositive. The negation of Q goes to the negation of P. So the negation of Q is going to be this piece here. So if I am, so we're negating that said I am not, so now it's I am afraid of heights. Oopsies, afraid of heights. Then I do not, we have to negate it, I do not ride on the Ferris wheel. Fantastic. Okay, we got our first section done. Let's keep going. Now we're down to skill 4E. It says use P and Q to write the following symbolic statements in words. So P is points X, Y, and Z are not collinear. Q is points X, Y, and Z are coplanar. And just as a reminder, remember, collinear means points that are together on the same line. So points on the same line, or points that are all on one line would be a better way to put it. Coplanar would be points on the same plane. So just as a quick reminder, but now let's do what it's asking us to do. This says squiggly Q. There's no if then because I don't have an arrow. All I have is the negation of Q. Well, how do we negate Q? It says points X, Y, and Z are coplanar. So the negation would be that points X, Y, and Z are not coplanar. You don't have to capitalize this and underline it, but it just makes it easier for us as teachers to see that you understand how to negate. Okay, 7, Q and, remember that A, that thing that looks like an A without the line in the middle is and if it were upside down. So this thing here is and, this thing here is or. I'll zoom in a little bit more really fast. Well, I guess I can't when it's filming. Okay, so Q and the negation of P. Well, Q says points X, Y, and Z are coplanar. Now you have to use that word and. Now we're doing the negation of P. Points X, Y, and Z. Well, this says are not collinear, so we're going to say they are collinear. So and points X, Y, and Z are collinear. Okay, down here we have the arrow. That means if then. The negation, the squigglies mean negation. So we're going to do the negation of P, the negation of Q with if then in between. So let's write that now. If points, I don't know why I'm capitalizing that. So X, Y, and Z are collinear, then points X, Y, and Z are not coplanar. Great. Okay, let's keep going. The bottom says fill in the blank with the correct response. If a conditional statement is true, then the blank is also true. If converse statement is false, then the blank statement is false. Well, remember in class we talked about something called equivalent statements. That's what these are talking about. So equivalent statements. So we're trying to figure out what's the equivalent statement of the conditional. Well, the contrapositive is the equivalent statement. Because if the conditional statement is true, the contrapositive will be true. If the conditional statement is false, the contrapositive will be false. Okay, the equivalent statement of the converse statement is the inverse. Oopsies. So if the inverse is true, the converse will be true. If one's false, the other one will also be false. So those are our equivalent statements. Okay, let's flip to the next page now. Okay, rewrite the following conditional as a biconditional statement, then determine if it's true. We can always write the biconditional, we just have to use the words if and only if instead of if then. That doesn't necessarily make it a true biconditional, so we'll talk about it in a second. So this says, if two segments are congruent, then they have the same measure. So there's P, there's Q, and what we have right here is P arrow Q. The biconditional wants P with an arrow going both directions Q, and that double arrow means if and only if. So the biconditional would say, so P first, two segments are congruent. Now this thing here means if and only if, so if and only if Q, they have the same measure. There we go. Our symbols for this, we just did a moment ago, was P, arrow, going both directions, Q. Well, now we have to figure out if it's a true statement. So we need to test both directions. First, I'm going to check P goes to Q. So if two segments are congruent, then they have the same measure. Well, something we need to be a little careful about. This should really say length instead of measure, but it is true. If two segments are congruent, then it means that they have the same length. So we're going to put that as true. Measure, we can still talk about as measuring the length of a line. We're measuring it has the same, but normally we use the word length instead of measure. Now we're going to do Q goes to P. We're going to go backwards. So if two segments have the same measure or the same length, then they are congruent. Yep, that's also true. So is this a biconditional true statement? Yes, it's true. And if this were on a test, we would be more specific with our language. We might have accidentally changed this from Ingalls a year before. So for now, we're going to leave that as true. On a test, we'll make sure our language is very specific. Okay, 13 and 14 here says, identify the following as either inductive or deductive reasoning. Remember, inductive is when we're using a pattern to draw a conclusion. So if we look at 13, it says 1, 2, 4, the next number in the pattern will be 8. They're drawing a conclusion based on a pattern. That's inductive reasoning. Then it has, if you get this question right, you will pass the test. You get the question right, therefore you pass it. This is the law of detachment that we're using. We're saying we have an if-then statement. They're saying that you got the questions right, so P happened, so therefore my conclusion was Q. That's the law of detachment, so yes, it's deductive reasoning. We're using the laws of logic. We're doing logical reasoning. Okay, 5C, give a counterexample for the following conjectures. It says all numbers are divisible by 5. Well, we know that's not true, so we just need to give an example of an odd number that's not divisible by 5. So an odd number that's not divisible by 5 is 3. Another example would be 7. Another example would be 9. Another example would be 11. So you just need to give one example of a number that's odd that's not divisible by 5. 16 says all dogs have black fur. Well, we know that's not true because we've seen dogs with other colored fur, so we just need to give an example. So an example would be golden retrievers. Or you also could have put chocolate labs, or you could put, I can't think off the top of my head, like a Bichon or something. Okay, so now let's go down to 5D. This is decide whether the following symbolic representations are correct. If not, correct the mistake. The law of syllogism. If G goes to H and H goes to I, okay, sorry, I probably noticed this on my hand. I have a class I have to do too, so pardon that, but okay. The law of syllogism. If G goes to H and H goes to I, then G goes to H. Well, that's not true because remember we normally make our train. So go G goes to H and H goes to I. So our conclusion is G goes to I. This is not right. We need to change that to I. The law of detachment says if A goes to B and A happens, then B will be true. Well, that's not what happened. It says B is true. That's the second part. So then A is true. That's wrong. So we need to change this. It says and A is true, then the second part, B, will be true. And an example I give in class is if you are an apple, then you are a fruit. If I tell you that you're an apple, then you're going to conclude you're a fruit. But if I tell you the second piece that you're a fruit, that doesn't mean you can go backwards and say that you're an apple. That's why the law of detachment only works going forwards. Okay. 5E, determine if a valid conclusion can be reached from the two true statements. If it can, state it, and the law that is used. If there is no valid conclusion, write no conclusion. So it says if a mineral is gypsum, there's P, then it has a hardness of 2. Oopsies, I should include that. Notice there's no word then here. You do need the if in the beginning, but sometimes there's an implied then. We can easily include the word then here, and it makes the same sense with or without it. So if a mineral is gypsum, then it has a hardness of 2. If a mineral is gypsum, it has a hardness of 2. That's fine. Then it says if a mineral has a hardness of 2. Well, that's Q. We've already seen that. Then it can be scratched with a fingernail. Well, that's something we haven't seen before. We need to give it a new letter. I'm going to call it R. Okay, well, the law of syllogism says if I have two different conditional statements and I can make a train, then my conclusion is going to be that first thing and that last thing. So that's going to be my conclusion. I'm going to say, and this has to be an if-then statement. And so if you didn't do that on the quiz, you might have gotten points off. So we're going to say if P, which is if a mineral is gypsum, then R, it can be scratched